Hello friends, we move on with our next problem solving session. Before going for this problem solving session is basically again for maximum power transfer theorem. We will see some different problem. Before going for this session, if you have still not subscribed, like and comment my channel, please do it. Once you subscribe it will be more easy for you to go through my all video in a sequential manner and one can easily understand this topic. Okay friends, so please subscribe it. And the link for my previous video is already mentioned in my description box. Please go through it just to follow these numerical problems. Okay, so we start with our next problem, and this is our next problem. So friends, again in this problem, see, this is the terminal AB and the load is RL equal to 8 ohm is connected. So basically in this question you have to find the value of R such that the maximum power transfer occur across load AB, that is RL equal to 8 ohm. So basically you have to find the value of R such that this network, that is the network which is left to the AB, will deliver maximum power to the load, that is RL equal to 8 ohm. So what does it mean? The meaning is, if the value of this entire resistance bay, if it is 8 ohm, then you can say under that condition only this entire bay, or you can say the network which is of left of AB, will deliver maximum power to the load RL equal to 8 ohm. So now the question comes to your mind, how we will find this value to get this entire value as 8 ohm. Now see, if I make R as 0, very important, if I make this resistance R as 0 ohm, what will happen? Now see, if R goes 0, that means from the Ohm's law, that is V equal to IR, I is V by R. If R goes 0, that means I goes infinite, or you can say this branch will be short circuited. So once this branch is short circuited, the resistance in parallel with the short circuit branch will also become short circuited. So your new network will become something like this in the case when you are finding RTH. Okay, so this is your short circuit branch, and again your resistance here is connected, and this is your load, that is AB, and this is your 16 ohm, this is your 16 ohm, and if you find the parallel combination of this 16 ohm, that comes to be what? It is 8 ohm. So what is the value of R? The value of R comes to be 0 ohm. Just keep in mind, by making R as 0 ohm, this network will deliver maximum power to 8 ohm. Okay, this question was asked in BARC. There is an organization known as Bhava Atomic Research Center, and in that question paper this question was asked. Okay, so this is the first problem. We move on with the next problem. Okay, so friends, this is your next problem. This problem was asked in DRDO. However, in DRDO they have only asked about the value of resistance RL, so that this network left to AB, terminal AB, will deliver maximum power to the load RL. But in this question I will specifically find maximum power also, just to understand this problem. Okay, this is one of the good problem. Now we will see, first of all we will find RTH. Okay, what we will find? We will find RTH. Now for finding out the RTH, what we will do? Our all independent source goes off. So this is your short circuited, this is your resistance, this is your current source which is open circuited. Okay, for the timing I am making here. This is your dependent source. So friend, I have redrawn this network. This is short circuited, this is open circuited. I will remove this just for your understanding I have made here. Okay, so this is basically open circuited. This is 2Vx, 2 ohm, and again I have introduced V theta and I theta, and you can say V theta by I theta is what? Your RTH, and that is equal to RL for maximum power transfer. Okay, so now we have to find the value of RTH. Now see, just consider that some current I1 is flowing here. So if I1 is the current flowing here, so what is the current here? It is I1 minus of I theta. Okay, So these are the two current which are flowing in this branch. This I1 minus I theta will come here, I1 will be added here, okay, and once friends, here I have considered I1 current which is flowing here. This I theta is current here. So what is the current here? It is I theta minus of I1. The current which is flowing here, that current comes to be here, I1 comes to be here. When both current added, the current here is I theta. So our current division is correct. Okay. So now what we will do? We will apply one KVL here, and one KVL here. Okay. And we will find the answer. So you can say V theta is equal to twice of I1. This is your equation first. Okay, the current I1. So you can say V theta is equal to 2 of I1. Okay. Similarly, when you talk about this mesh, you just apply one loop. So how much it is? It comes to be minus of twice of Vx, because we are moving in this fashion. So it is plus 2 minus of 2 Vx, that is equal to what? It is 2 into I theta minus of I1 and minus of 2I1. This is our equation 2. Or you can say it is minus of Vx, that is equal to I theta minus of I1 minus of I1, or you can say it is Vx is equal to 2I1 minus of I theta. Yes, this is your equation 2. Simply we have just solved this equation and find the value in terms of Vx, I1 and I theta. Now you have to find the value of I1 in terms of I theta. So you have to replace Vx. Now how you replace Vx? Please see. This is your Vx. I am redrawing Vx here. Just see here itself. This is your Vx. This is your 2 ohm resistance, and this is your Vx. This is your 2 ohm resistance, and the current which is coming here is what? It is I theta minus of I1. So you just apply loop in this fashion. So the value of Vx comes to be how much? It is 2 into I theta minus of I1. Very important. You have just apply loop in this fashion. So minus 2 plus Vx, that is equal to 2 into I theta minus of I1. Okay. So like that we have find the value of Vx. Now what we will do, we will put this value here. Now see. So that comes to be how much? It is 2 of I theta minus of 2 of I1, that is equal to 2 of I1 minus of I theta. Okay. So that comes to be how much? It is 3 of I theta, that is equal to 4 of I1, or you can say I1 is 3 by 4 of I theta. So now I put this value here. So here V theta comes to be how much? It is 2 into 3 by 4 I theta, or you can say it is 3 by 2 I theta. Okay, or you can say it is RTH, or your RL is 3 by 2 ohm. Okay, so this you have find the value of RL. So with this this one portion is finished, and it was asked in DRDO question, that is 3 by 2 ohm. This is your value of RL. Okay. Now our next task is to find the value of maximum power, and for finding out the maximum power, what we will do? Now we have to find the value of maximum power. So this is maximum power we will find across the terminal AB. So now the voltage which is appearing here is VTH, that is open circuit voltage. So basically you have to find the value of VTH, and once you know the value of VTH, your maximum power you can say it is P max. P max is what? It is VTH square upon 4 RTH. Okay. So this is the value of maximum power you can find. So you have to find the value of VTH. Now we will see how we find the value of VTH. Okay. Now for the time being, let's consider some current is flowing here, and I call that current as I1. Okay. So what is the current here? It is I1 plus 6. What is the current here? I1 plus 6. Why? Because it is open circuit. Same current will flow here, 6 ampere will go there, and I1 current is flowing here. So this is our simple current division. So from here you can say that the value of VTH is what? It is 2 into I1 plus of 6. Yes. Or you can say it is 2 of I1 plus of 12. This is your first equation. Basically you have to find the value of I1. Now how you will find the value of I1? What we'll do, I am applying 1 KVL here. Okay, so that comes to be how much? It is minus 2 plus 36 minus 2 plus 2Vx is equal to this voltage source, this voltage source. You are applying in this fashion. First resistance you will get 2, the current flowing is how much? It is I1 plus of next resistance you will get 2, the current flowing is I1 plus of 6. Okay, so just solve it. It is 18 plus of Vx is equal to I1 plus of I1 plus of 6. Okay, so from here 18 plus Vx comes to be twice of I1 plus of 6. This is your equation second. Now you have to find the value of Vx in terms of what? I1. So from this, can you say this is your Vx, that is minus 2 plus Vx, and this is your current I1 and it is 2 ohm. So can you apply one loop here? Yes. So the value of Vx comes to be how much? That comes to be minus 2 plus, it is minus of 2 I1. Now I will put this value here. So that comes to be 18 minus of 2 I1 is equal to 2 I1 plus of 6. And just solve it. It comes to be 12 is equal to 4 I1, or you can say I1 is equal to 3 ampere. So once you get the value of I1 as 3 ampere, you can find the value of VTH. So that comes to be how much? Your value of VTH comes to be 2 into 3 plus of 12, and that comes to be 18 volt. Okay, so this is the value of your VTH. So now once you get the value of VTH, your maximum power Pmax is equal to VTH square, that is 18 square upon 4 into RTH. RTH is how much? It is 3 by 2. So that comes to be how much? 54 watt. Okay, so with this we have find the value of Pmax as 54 watt. So this is one problem important just to understand. First we have find the value of RL, then we have find the value of VTH. How we find value of VTH when dependent source is also present? So this is the fashion we have find, and finally we have find the value of maximum power. So we move on with the next problem. So friend, this is your next problem. In this problem, you have to find the value of VTH, Thevenin's voltage. You have to find the value of Thevenin's voltage, so that maximum power transfer, and that the value of that power is how much? It is 16 watt. It means if this is your terminal AB, so as per the question it is given that you have to find the value of VTH so that this network will deliver maximum power to this load R, and the value of that maximum power is how much? It is 16 watt. So you can say that the value of Pmax already given as 16 watt. Okay, or you can say it is given as VTH square upon 4 RTH. Now to find the value of VTH, you have to find the value of RTH. Okay, so we redraw this network here. Please see, your voltage source gets short circuited. This is your resistance, this resistance, and your current source get open circuited. Again this is your resistance, it is short circuited, and this is your terminal. So this will be your RTH. Okay, this will be your RTH. So what is RTH? See, there is no mean of this branch. Why? Because it is open circuit. Please keep in mind this is open circuit, so there is no mean of this branch. I will simply remove this branch. Okay, okay. So from here these 2 ohm resistance are in parallel, and it is in series with 1 ohm plus 2 ohm. So 2 parallel 2 comes to be 1 plus 1 plus 2, so that comes to be 4 ohm. So this is the value of RTH. Okay, very simple. And once you get the value of RTH, the value of VTH square from here comes to be Pmax, that is 16 into 4 into RTH is again 4. So the value of VTH comes to be 16 volt. Very important. This is the value of Thevenin's voltage applicable. Okay, so with this problem is finished. This is also an important problem. You move on with the next problem. So this is your next question, in which you have to find the value of I so that the maximum power delivered to load AB, or you can say across AB. Basically this is a load which is connected across AB. So basically you have to find the value of I so that maximum power delivered to load AB. Then you have to find the value of maximum power delivered. Okay, so these are the two things you have to find. Now we will see how we will find this. So for finding out maximum power, please keep in mind you have to find RTH. Okay, as we know that. But this question is little bit different in the sense that if I draw its equivalent, so this is its equivalent. This is your RTH and this is your VTH, and here is AB terminal. Okay, and the current flowing is I say let some voltage is appearing here, that voltage is VAB. So basically to find the value of I or maximum power, first you have to find the value of VTH, okay, and RTH also. Okay, so we will see how we will find that value. So first of all we will find the value of RTH. So just to find the value of RTH, we remove it, and this will be get short circuited. So you can say I am redrawing this network here. So that comes to be how much? It is in this form. And this is your two terminal from where you have to find RTH. This is your 4 ohm, this is your 4 ohm, this is 3 ohm, this is 6 ohm. So what is RTH? RTH, as I said, it's kind of bridge in which 3 is parallel to 6 ohm plus 4 is parallel to 4 ohm. When you keep this terminal in this fashion, just unfold it. So these 3 and 6 ohm and this 4 and 4 ohm comes to be in parallel. 3 parallel 6 comes to be 2. 4 parallel 4 also comes to be 2. So the value of RTH comes to be 4 ohm. Okay, the value of RTH comes to be 4 ohm. Now our next task is to find the value of VTH. Okay, so when you are going to find the value of VTH, you have to make this as open circuit. Now see, for finding out the value of VTH, what I will do, I will make it as open circuit voltage. So this is basically your terminal, and here your VTH is connected. This is VTH. Okay, so as I said, VTH, for finding out VTH, you can say VTH is the voltage difference at terminal A and at terminal B. I earlier told you about this VA and VB. So the value of VA is what? This potential will appear across this and this resistance B. So if you find A, this is A and this is B. Okay, so if you find VA, VA is what? The voltage across 6 ohm resistance. So it is 6 into 48 divided by 6 plus 3, just by applying voltage division rule. Similarly, what is VB? VB is the voltage across this 4 ohm resistance. So again it is 48 divided by 4 plus 4. So your VA comes to be how much and your VB comes to be how much? VA is how much? It is 6 into 48 divided by 9, 3233, and how much it is? 32 volt. Okay, and what about this? It is 4 into 48 divided by 8, so that comes to be 24 volt. So your VTH comes to be VA minus of VB. So it is 32 minus of 24, that comes to be how much? 8 volt. So this is the value of your Thevenin's voltage. Once you know the value of VTH, okay, you can easily find the value of maximum power transfer. Okay, now the question comes to your mind, how we find the value of I. See, this is one method in which we have find the value of maximum power with the help of VTH and RTH. But if you have to find the value of I, how we'll find? So see, first of all we'll find the value of maximum power. Okay, so what is our maximum power? Maximum power P max comes to be how much? It is VTH square upon 4 RTH. So that comes to be, VTH is what? It is 8 into 8 divided by 4 into RTH is 4. So that comes to be 4 watt. So here maximum power P max comes to be how much? 4 watt. Okay. Now to find the value of I, please see, should I apply this loop? Yes. So if I apply this loop, you can say that VTH, please see here I am applying the loop, VTH minus of VAB is equal to RTH into I, or you can say VTH is how much? It is 8 minus of VAB is equal to RTH is how much? It is 4 into I. Yes, or you can say the value of VAB is how much? It is 8 minus of 4I. This is the value of VAB, that is 8 minus of 4I. So if you see the power across this current source, so that comes to be PAB is equal to what? VAB into I. Yes, very simple. Here this I is basically I am taking as capital I. Okay, just do not confuse, I am taking it as capital I. So you can say it is 8 minus of 4I into I, so that comes to be 8I minus of 4I square. So this is your PAB. Now for maximum power, you can say that dPAB upon di goes to 0. Yes, for finding out the maximum power, dPAB upon di goes to 0. So if you find the differential of this, it comes to be 8 minus of 8I is 0. So the value of I comes to be how much? It is 1 ampere. With this you have find another answer. And once you know the value of I equal to 1 ampere, you can put here and find the value of PAB. And under that condition, PAB will become maximum. So that comes to be how much? 8 minus of 4. That comes to be 4 watt. So from here I have just tell you like that you directly find the value of I 1 ampere and P max 4 watt, and from here also we have just find the value of RTH and then we have find the value of maximum power. So there are the two way through which you can find the maximum power also, VTH also and I also. So this is your one type, a kind of descriptive power in which we have just understand the concepts. So for finding out the value of I and maximum power, you can directly apply this method and one can get the answer. Just to analyze it or to see whether it is correct or not, we have just gone through this method also. Okay, with this problem is finished. Okay friends, we now start with our next and the last topic. This is not a problem. I am going to explain you some concept of efficiency and maximum power transfer. Sometimes you will find such type of question used to come in engineering services and other PSU examinations also. Okay. Now, first of all, we'll see what is efficiency. You know, you have go through your subject, so you have you know about that. What is efficiency? Efficiency you can call it generally it as output upon input. Okay, output upon input. Now whatever the terms, you call it as output upon input and you will find the efficiency. So in case of maximum power transfer, if you talk about the efficiency, you can say that the output power at load upon total power supplied. Yes, or you can say output power at load, it means dissipated, or you can say it is dissipated. So if I call eta here, you can say it is PL upon PS. PL is the power dissipated at load and PS is the power supplied. Okay, so you can say that yes, the efficiency is what? PL by PS. Now if you talk about PL, what is PL? If you talk about PL you can say that it is VL into I. VL, the voltage across the load, and the current I. Similarly, you can say what is PS. PS, you can say the total power which is generated by the source, you can say it is VS into I. Yes. So PL you can write here it as VL into I and write it as VS into I, or you can say it is VL upon VS. Now if you talk about VL and VS, VL is what? It is I into RL upon VS is what? VS is what? The total. Okay, VS is what? Is the total. So you can say it is RS plus of RL into I. Just write it here. It is a source resistance RS. Okay, this is a source voltage VS, this is source resistance RS, and across the terminal AB some load is connected. So basically we are trying to relate a relation of efficiency, that is your output power, that is output power which is in the load upon the total power which is supplied by the source. Okay, so you can say that the efficiency comes to be what? It is RL upon RS plus of RL. So in case of networks, you can say that the efficiency is defined as RL upon RS plus of RL. Very important formula. Okay. Now there are certain conditions we'll see in this regard. Okay. Now friends, please try to understand the very basic concept here. I have taken RL as 0. We'll take condition of load resistance. Okay, when RL is 0, eta goes 0, so that is 0%. When RL goes infinite, it means your efficiency will become unity and eta 100%. This is just a theoretical case, and the very important case is RL is equal to RS. When RL is equal to RS, that means eta is goes 1 by 2 and you can say efficiency is 50%. What does it mean? We know that in the condition when load resistance will become equal to source resistance, the maximum power transfer occur from this network to the load. Okay, this we have seen in our maximum power transfer theorem. So what I want to explain you here is that the maximum power in a network does not raise a condition that your efficiency also get maximized. Okay, so you can say that the maximum power does not result in maximum efficiency in the network, because we are analyzing that when a maximum power transfer occur in a network, your efficiency goes around what? 50%. It is in the condition when the maximum power is now delivered by network to the load. So this is a very important concept in which you just try to understand that the maximum power in a network does not result in a maximum efficiency. Very important statement. The maximum power in a network does not result in a maximum efficiency. Okay, so this is one very important statement. You will find such type of problem used to come in exams. Okay, so this is all about the efficiency. So this was just a concept. With this topic is finished. Okay.